Life of a star. How long will our sun be around? When we look up at the night sky, the stars never really seem to change. In fact, throughout your lifetime, the stars may never change. Night after night, century after century, people have assumed that they will last forever. The Greek philosopher Aristotle even proposed that stars were made of unique elements not found on Earth. Since Aristotle's time, astronomers have discovered that the stars, like people, have finite lives. Stars are born from great reservoirs of cosmic material and are the most common elements in the universe. They shine with immense brightness and give us energy for millions, if not billions of years. However, stars do exhaust their energy supply and eventually fade and become extinct. Understanding the life of a star has been one of the most significant tasks of astronomy. During the last 100 years, astronomers have made remarkable progress in tracking the progression of stages of a star in space. Welcome to Brainbender Solarium. Join us as we travel through space and explore the life of a star, as well as the life of our closest star, the Sun. A supernova is a powerful and luminous stellar explosion. During the last evolutionary phases of a star, or when a white dwarf is triggered through runaway nuclear fusion, this transient astronomical phenomenon occurs. The most famous supernova in history occurred in July 1054. Records of this occurrence still survive from China to North America. Roughly 1,000 years later in the present time, its remnant is called the Crab Nebula and is one of the most interesting objects in the night sky. You can find it with a good pair of binoculars or a small telescope within the constellation of Taurus. Every star leaves behind a corpse star. Corpses come in two bizarre varieties. A white dwarf fades away as billions of years pass since no energy is produced inside it and light is escaping into space. The star's corpse slowly cools down and becomes black as space. Astronomers call these corpses black dwarfs. A supernova explosion leaves behind a far more compressed corpse. A violent end to a massive star produces so much pressure that the star's core experiences a remarkable change. Electrons, negatively charged particles that orbit the nucleus of an atom, are squeezed into the nucleus. The electrons join with protons, positively charged particles, to become neutrons, neutrally charged particles. The process also removes all the space inside the atom, leading to significant compression of a star's remnant. To make something as dense as a neutron star on Earth, we would have to take all the people in the world and squeeze them into the size of a raindrop. If the dying star is especially massive, the remnant becomes a wholly collapsed object known as a black hole. Within these entities, gravity is so strong that nothing, not even light, can escape. Space, time, matter, and energy are all trapped within the tiny region. Understanding the behavior of black holes is one of the great frontiers in the area of astronomy. So, by looking at the life story of a star, you might be thinking, how does this influence human life here on Earth? What's so important about the life and death of previous generations of stars when it has nothing to do with humanity? Stars have a chemical makeup. It all started when the universe began with only the two simplest types of atoms, hydrogen and helium. It is impossible to make something as complex as a human being out of just these two elements. You need more stuff. You need things like carbon, oxygen, calcium, iron, and a host of other atoms to make a human being or to make any other life in general. So where do these heavier elements come from if they were not present at the start of the universe? Well, heavier atoms were produced by diffusion. At the center of stars, we see evidence that stars create new elements in the process of making energy. When stars die, especially the ones that become supernovas, they seem to recycle their material by releasing these newly created elements into the cosmos. The next generation of stars then form from these enriched mixtures of elements, and so do planets. It took several generations of stars to enrich our neighborhood so that when the Sun and the Earth were formed 5 billion years ago, they would contain enough of the heavier atoms to make living creatures. Apart from hydrogen and helium, every atom inside of the human body was once part of the inside of a massive star. From this process, new life can be created for new stars and new planets and new organic creatures. The Sun is in the main sequence phase of its existence, as are many stars in our universe. This means that hydrogen fuses to helium through nuclear fusion reactions within the sun's core. However, because the sun's core has a finite amount of hydrogen, this process will not continue indefinitely. It contains more than 72% hydrogen at present. 1 billion years from now, the sun will be 10% brighter than it currently is. This will trigger a moist greenhouse effect here on Earth that is similar to the hellish Venus environments that we see today. Life as we know it would be unable to survive anywhere on the Earth's surface under these conditions. So, when will the sun run out of fuel? The sun will run out of hydrogen fuel one day. This process will begin in around 6.4 billion years, at which point the sun will leave the main stage of its life in sequence. The inner helium ash built up there, with its hydrogen depleted in the core, will become unstable and collapse under its weight. In a shell around the dead core, the helium will begin to fuse. Then our star reaches the red giant process and swells up even more rapidly. The growing sun is estimated to grow big enough to encompass the orbits of Mercury, Venus, and maybe even Earth. Things will end one day. What usually comes to mind when people think of stars dying are massive supernovas and black holes forming. However, this will not be the case with our sun because it is so big. About 1 billion years after the sun tries to swallow Earth, the red giant will undergo a process called a helium flash, where huge amounts of helium fuse to carbon in a matter of minutes. Once the helium in the core starts fusion, the star will shrink but gain luminosity. Over the next 20 million years, the sun will become unstable and begin losing mass through a series of thermal pulses. These powerful bursts of radiation will cause the sun to fling wave after wave of material out into space. After about 500,000 years of these stellar tantrums, the sun will have tossed away half of its mass. A beautiful planetary nebula will momentarily shape the discarded stuff. Ultimately, the remnant will cool and become a white dwarf consisting entirely of carbon and oxygen. Before fading to darkness, this smoldering ember will shine for trillions of years. We have many days ahead of us filled with sunshine to look forward to. Nothing is for sure, and that's why we have to keep marching forward. After all, the world, let alone the sun, will not slow down so we can catch up. Thanks for joining us. We hope you found this video interesting. If so, take a look at some of our other videos you see on the screen now. Also, ring that bell to keep up with new content that we publish weekly. We'll see you next time, here on Solarium.